Hello, today we are going to be looking at notes 3-5, three variable systems with substitution. So we are going to use substitution to solve the following system. So again, we have a three variable system and three equations, and we are going to use substitution. So our very first step, just like before with two variables, is to isolate a variable in one of the equations. So looking at these equations here, I notice these two equations only have two variables. Okay, I also noticed that this equation, what's nice about it, is that this variable here, the x, has a 1 for a coefficient. So that will be very easy to isolate because I won't have to divide. So I'm going to choose the second equation here, and I'm going to take it, and I'm going to isolate x. So that means I need to get rid of this 5y. So I'm going to move the 5y to the other side, so this would become x equals negative 5y plus 9. Okay, now that I have isolated a variable in one of the equations, step number 2 is to substitute the expression. So that means what the variable equals, that means this. Substitute the expression into the other two equations. So that means I'm going to take what x equals, which is this, and I'm going to substitute it into the other two equations that I haven't messed with yet. So that means the top one and the bottom one. So in the top equation, I've got 2. Where I see x, because this is what x equals, I'm going to substitute negative 5y plus 9, and then plus 3y minus 2z equals negative 1. Okay, and then I'm going to go ahead and solve that or distribute that and make it look nice and neat, clean it up. But let me go ahead and write this bottom equation. I've got 4z minus 5x, but again, where I see x, I'm plugging in this negative 5y plus 9 equals 4. Okay, and now I need to clean both of these up. So on this one here, I'm going to distribute the 2, so negative 10y plus 18 plus 3y minus 2z equals negative 1. Now I can combine some like terms. I've got a y and a y. So negative 10y plus 3y would give me a negative 7y. I've only got the one z, so I'll leave it, negative 2z. And then this 18, I want to move it to the other side, right, to get it in standard form. So I'm going to move the 18, which means I'm going to subtract 18. So this would become negative 19. Okay, so now clean up this one, 4z. When I distribute, plus 25y minus 45 equals 4. I don't have any like terms to combine here. So to clean it up, first of all, y should go in front of z. So 25y plus 4z, and that negative 45 needs to move over, so it's going to become a positive 45. When I combine it with the 4, oh, I guess, hello, I don't need to write the plus. That will be a 49. Okay, so now that my equations are cleaned up, my step number 3 is to write the two new equations as a system and solve. So I've got two new equations here that I can rewrite as a new system of equations and solve. So I've got negative 7y minus 2z equals negative 19, and 25y plus 4z equals 49. And I'm looking at this and I'm thinking, well, I have lots of different ways that I know how to solve systems. The easiest way algebraically is probably not going to be substitution because all of these have coefficients other than 1. So if I need to isolate a variable, that's going to be tough. I look at these two equations and I say, look at those two numbers. Okay, if I went to add this up, I could easily cancel z if I multiply this top equation by what? You're screaming at home, right? 2. So if I multiply this top equation by 2, negative 14y minus 4z equals negative 38, and then rewrite the bottom as it was, 25y plus 4z equals 49, and look at that. So now when I go to add, I can use elimination, that's okay. All right, so when I add these, I get 11y, this cancels, equals 11. I add that up, and then divide both sides by 11, and I would get y equals 1. So I have finally solved for one of my variables. So step 4 is plug answer into one of the new equations. Okay, so we're talking about one of the two of these, my newer equations. So it doesn't matter which. This is negatives, but that's much larger numbers, so I'm going to go ahead and choose this one. So negative 7, where I see y, I'm replacing it with 1, minus 2z equals negative 19. So here that would give me negative 7 minus 2z equals negative 19. I go to add 7 to both sides. I get negative 2z equals negative 12. And then divide both sides by a negative 2, which would give me z equals 6. So you guessed it, I'm to my final step here. Step 5. Plug both answers into original equation and solve for the third variable. So now I know what two of the variables are. I know what y and z are. So I can go ahead and take those, plug it into one of my original, and solve. So if you're looking at your paper, which hopefully you have handy, you're going to have to, let's see here, I'm looking for x. So all of these equations have x. I could use any of the 3. So if I use one of the bottom 2, it's nicer because it's smaller. So let's just go ahead and use this middle one here. So I would have x plus 5, where I see y, I'm plugging in, remember y was 1. So where I see y, I'm plugging in 1 equals 9. And so I would get x plus 5 equals 9. Subtract 5 from both sides, I get x equals 4. So now I've got my triple. I've got 4, which is x, comma 1, which is y, and 6, which is z. So that is my final solution.